Hey, do you want to learn how to create a hilarious dad joke dApp? In this tutorial, we'll be using Next.js, Tailwind, a smart contract, and Vim to build a fully functional dad joke dApp. Now, many developers struggle to get started building a dApp because they aren't sure how to connect all of the different pieces. In this tutorial, I'll walk you through the process step by step and show you how to create your smart contract, build a front end with Next.js, style it with Tailwind, and use Vim to connect it all together. By the end of this video, you'll have a fully functioning dad joke dApp deployed on Sepolia and the skills and knowledge to start building your own dApps. So let's get started. All right, so let's take a minute to talk about what we're actually going to be building and what it looks like. So here you can see we have our dad jokes dApp. Dad jokes, they used to be off the chain, but now they're on chain. We have our joke here, not false. It's funny because it's true. And we can look at some different jokes as well. We can also connect our wallet, our MetaMask wallet, and reward the joke. So you can submit a joke, it gets stored on chain. We can reward the joke if it's funny, really funny, or a groaner. Based on that, we can reward the joke and the joke's creator. Once we've rewarded the joke, the creator can then cash out if they've been rewarded and get that value back from our application. So that's the basics of what we're going to be building. Where are we going to start? We're going to start with Remix, and we're going to build our smart contract there just to keep things as simple as possible. So we'll head on over to remix.ethereum.org. So we've got our new workspace called Dad Jokes. We'll create a new file here, and we'll go ahead and call it dadjokes.sol. All right, so we've got our dad jokes file created. The first thing we'll need to do is we'll need to actually make the contract within this file. So we have our license identifier, our compiler version, and the contract name, dad jokes. Within the contract, we'll need to create a struct for the joke, basically mapping out what a joke contains. So a joke's going to contain a setup, a punchline, the creator, and whether or not it's been deleted. Now, in the blockchain environment, we can't really delete things because those transactions are there forever, but we can mark them as deleted and clear out everything within the joke so that it doesn't show up. So next, we have a mapping of the jokes that we'll be creating. Here we map a joke ID to the actual joke that we're using from that struct above. We're calling that mapping jokes. And then we have a uint256 to keep track of how many jokes we have. We're going to have a mapping of the balances as well. So the address of the creator to the balance that they have. This way, when a joke gets rewarded, we can keep track of those values as well. Next up, we've got some constants for our classic reward, our funny reward, and our groaner reward. You know, groaner being the best. The best dad jokes make you go, ugh, that was a terrible joke. Once we've defined those constants, we then create a mapping of the reward amounts. So this mapping will be used to map the reward number that we'll pass in from our front end to the amount. So 1 being classic, 2 being funny, 3 being a groaner. We have our constructor here. So we're using that mapping of reward amounts to map the reward type to the amount in our constructor. And the constructors run every time that the contract is deployed. So it's only run once, but anytime this contract's deployed, that constructor will run. It's basically just setting up our reward mapping. Once we have our constructor created, we then can create some events. Events in Solidity are kind of like logs. When something happens, we can emit an event, and that will keep track of that event happening. It's like logging for Solidity. So we have events for our joke added, where we'll include the joke ID and the creator. We have a reward where we say what the joke ID is, the reward type, and the reward amount. We also have if a joke is deleted, and then if a balance is withdrawn. So that's when a creator removes their balance from the smart contract. Once we have those events created, we then create our first function, add joke. And this will allow us to take a joke as input, the setup and the punchline, and add it to our mapping that we created above, jokes. So we take our jokes, we say, what's the current joke number? That's going to be the ID that we're using. We then add in our joke with the setup, the punchline. Message.sender is the person who's actually doing this interaction with the blockchain. So we include them, their address. They're the person creating this joke. And false for is deleted. So these map to our struct that we created up above, right? So we have our setup, our punchline, our creator, and whether or not it is deleted. We then emit our joke added event, and we increase the joke count by 1. So the next time we come in to add a joke, our joke count has been incremented. We've added jokes. Now we need a way to actually return the jokes back to our front end. And the way that we do that is we'll create a function called getJokes. This one's going to be a public view. That means anybody can call it. It's a view, which means it's just going to read data off the blockchain. And it's going to return an array of jokes. So our joke array that we're going to be returning is going to be called all jokes, and it's going to be a new array of jokes, the size of joke count. We're going to have a counter to keep track of how many jokes we've added to it, and we'll see why in just a moment. So the first thing we're going to do is we're going to go through each joke and see if it's deleted. If it's not deleted, then we'll go ahead and add it to our all jokes array that we created above, and we'll increment our counter. The reason we're keeping track of this is because we want to return the right size array when we're done. Once we have gotten all of the jokes, then we'll go through and we'll check and see if our counter is equal to our joke count. If there is, no jokes were deleted, and we can just return them all. But if a joke was deleted, we need to filter it out to return an array that's the right size. You remember when we created our array, we did it for every joke, and now we want to make sure that we're only returning an array that's the size of the jokes that were not deleted. So we'll go ahead and create a new array called filtered jokes here that's going to be based on the counter that we were incrementing every time we added a joke. And then we'll add all of our jokes to that filtered jokes array and return that back. This is how we can get all the jokes and only include the ones that weren't deleted. This is what we'll be using on our front end to view all of the jokes. Once we have all of our jokes returned, we need a way to reward jokes. And so let's create a function called reward joke. Within this function, we're going to have a few things. The first is we're going to make sure that the joke is a valid joke, right? So our joke ID actually exists. We need to also make sure that the reward type is 1 to 3. Those are our 3 different levels of rewards. And we want to make sure that we're not rewarding a joke that's already been deleted. So that's what these require statements do. They say, hey, require that this is true. If it's not true, give this error. So once we've checked and made sure the joke exists, the reward type is valid, and it hasn't been deleted, we need to also check and make sure that the amount passed in matches our reward amounts. So we'll go ahead and get the reward amount based on the reward type that was passed in, and we'll check and make sure that the value sent along with this function is correct. If it's not, we'll throw another error. And finally, we'll go ahead and increase the creator's balance by the reward amount that was passed in with this message. We'll emit our joke reward. So we'll say, hey, this joke ID got this reward type and this amount, and that's it. That's how you reward the joke. So we pass in our joke ID and our reward type. We do some checks, and then we go ahead and increase the creator balance by the reward amount. The next function that we need to build is one to actually delete the jokes. Now, remember, I said that we don't actually delete the jokes. So we're just going to blank everything out and set them to deleted so they don't show up on the front end. For our jokes to be deleted, we'll pass in the joke ID. We'll make sure that it's a valid joke ID. We'll also make sure that the joke creator is the same person who's requesting to delete it. So only the joke creator can delete their joke, and make sure it hasn't already been deleted. If it passes all of those requirements, then we'll go ahead and set that joke's information to blanked out, setup, and punchline. We'll set the creator address to 0, and we'll set it to is deleted at being true. And we'll go ahead and emit a joke deleted event with the joke ID. And finally, the last function that we're going to be adding to this smart contract is one for the creator to withdraw their balance. So we have a function called withdraw balance. We'll go ahead and get the balance of the creator that is calling this function. So that's going to be the message.sender. We're going to make sure that their balance is greater than 0. Otherwise, they can't withdraw anything. Then the first thing that we're going to do is we're going to set their balance to 0. This makes sure that before they get paid out, they have their balance set to 0. It prevents reentry. It prevents them from calling this multiple times. Then we'll use payable.call to actually send them their balance. So this actually withdraws the balance for that creator. Make sure that it was successful, and then emit a balance withdrawn with the creator's wallet address and the balance that was withdrawn. And that's it. That's the entire contract. It's pretty simple. Let's look through it one more time and see what we have here. So we have our struct setting up what a joke looks like. We have some mappings, one for the joke, one for the creator balances. We can keep track of how many jokes there are with joke count. We have our reward amounts. We also have a mapping for our reward amounts based on the reward type 1 through 3. We set those up in the constructor. We have our events that we emit, one for joke added, which has the joke ID and creator, one for reward, one for joke deleted, and also for balance withdrawn. We have functions to add jokes, get the jokes, reward the jokes, and delete the jokes. And then finally, we have a function to withdraw the balance for the creators. So once we've got this created, what we're looking for on the left-hand side of Remix is this green check mark that makes sure it's compiled. I have auto compile turned on. If you don't have that checked or you don't see a green check mark here, you might want to do that. If you don't see a green check mark after that's clicked and you've turned on auto compile, you've clicked compile, you still don't see that green check mark, something's probably wrong, like oops, this is wrong. And you'll see you may have errors, you may have a warning. You'll need to look and see what the issue is and take care of it. But Remix is pretty nice. It'll help you out and let you know what's going on. So we've got our green check mark there. Let's go to deploy and run. Now, the first thing to know is that we'll need to change our environment from Cancun to the injected provider. And I'm using Sepolia. So our injected provider will deploy us to Sepolia test network, and we can just make sure that our contract dad jokes is selected and click deploy. MetaMask will prompt us, we'll confirm this transaction, and then we'll be taking a look down here for a green check mark, as well as our contract to show up here under the deployed contracts. So we got a green check mark. That means that it was successfully deployed, and we can see our contract here, dad jokes, with all of our different functions. So we have add joke, delete joke, reward joke, withdraw balance. We can check our balances for the creators, and we can get all jokes. So if we call get all jokes now, it's going to return an empty array. So let's go ahead and add a joke. We'll just add that classic one, bang false. And we'll say it's funny because it's true. Click transact, confirm this transaction to add our joke to the blockchain. All right, our transaction has been completed. If we click get jokes now, we should see our setup, bang false. And then our punchline, it's funny because it's true. That's my wallet address, and false because it's not been deleted. All right, awesome. At this point, our smart contract is set up and ready to go. From here, we're going to transition into building out our Next.js front end. Our smart contract is deployed. So let's go ahead and create our next application. We'll start off by running npx create next app at latest. Say yes, it's okay to proceed. We'll go ahead and name this project Dad Jokes. We'll not use TypeScript for this example. We will use ESLint and Tailwind. We'll use a source directory in the app router. Won't customize the import alias, and we'll press return, and it'll begin installing everything for our project. All right, our project is created. We'll go into the Dad Jokes directory, and then we can run npm run dev. This will actually start up our Next.js server on port 3000. So that's where I was running the example app before. If I refresh now, we should see the basic Next.js application. So we're going to get rid of all of this because we don't need any of it. So how do we go about doing that? Well, I'm going to be using VS Code. So we'll go ahead and stop this application from running. I'll open it up in VS Code and we can go from there. So within our project, we have a couple of folders here. We have public and we have source app. Within source app, we have our page.js. So this is where that code is living currently for the homepage. So go ahead and delete the code that's powering this homepage right now and replace it with something very basic. We won't need image, so we can take that out. So let's go ahead and get rid of everything in here except for a div that says hello. Looks like we added an extra value there. So we've got our div that says hello. If we go back to Brave, we'll see the site can't be reached. That's because I stopped it from running. So within VS Code, I'll go ahead and open up my terminal and say npm run dev. Go ahead and start this back up on port 3000. Check it out in Brave now. When we give it a refresh, we'll see we have a bunch of crazy formatting on these lines and the word hello. This is our gradient background. It looked really nice with Next.js, but not so nice now. So let's go ahead and add some style to our application really quickly. This is using Tailwind .css. So in our Tailwind config, we have our background image, which is this gradient. Let's go ahead and change this config just a bit. So within the theme, I'm going to go ahead and delete the background image here, and we'll add a few things in. So the first thing that we're going to add is a new background image. I call this my person background. It's going to look like a dad. We've got a top that is going to be like a white polo shirt, a belt that's nice and brown, and then some khaki pants. You'll see it in a minute here once we give this a save. After that, I'm going to add some primary and secondary colors for light and dark, just kind of an off-white color, as well as a nice classic blue color. And then finally, what dad joke app would be complete without a Comic Sans style font? So this Comic New is a Google Fonts version of Comic Sans, and that'll give us a nice style for our font styles. So give this a save. We also need to edit our global.css as well. The first thing that we need to do is we need to import our Google font. So here's that fonts.google APIs, and it's the Comic New font. We'll go ahead and give that an import so that we can use it within our application. And that should be all that we need to do in our global.css. Within our layout, we can go ahead and edit a few things as well. The first is the metadata. We'll go ahead and replace this metadata with our dad jokes. Jokes so bad, you might just be a father. And give it a save. We'll go back into our page. For our div here, we'll go ahead and give it a class as well. Just a few things for spacing and stuff like that. We've got our person background here. Give it a save. Take a look, and you can see now that our page is wearing its nice polo shirt with a belt and khakis. All right, we haven't styled our font yet, but we'll get to that in just a moment. The next thing that we need to do is to prepare to use VM and our smart contract to interact with the blockchain. So I'm gonna go ahead and stop the server from running, and I'll run npm install VM. And this will get VM installed for us so that we can use it to interact with the blockchain. So what is a VM? Let's take a look real quick. VM is a way to interact with EVM blockchains. So there's Ethereum virtual machine style blockchains. It is a really easy, nice package to use. We'll be using that to actually do the interactions with the blockchain and bring them into our front end. So we installed VM. And the other thing that we'll need to do is to get our smart contracts ABI, or application binary interface. Think of it kind of like an API, but for smart contracts. It's defining how to interact with our smart contract. So we'll come here, we'll copy this to the clipboard. This is from the compiler tab. We'll go ahead and click on the ABI down at the bottom, copy it to our clipboard, and then we'll go into our application. Under source, I will make a new file that we'll call lib/, and then we'll call this dadjokes abi.json. And here we'll paste in the ABI that we copied. Give this file a save, and you'll notice that we created both the directory lib and the abi.json itself all at one go. So that will let us have everything that we need to interact with our smart contract on the blockchain. So the next thing that we'll need to create is a client to connect to the blockchain. So inside this lib directory, we'll create another new file. We'll call it client.js. Inside of here, what are we going to do? Well, the first thing we're going to do is we're going to import a few things. So from VM, we're going to create a wallet client, a public client. We're importing in custom and HTTP, as well as the Sepolia chain. If you remember, Sepolia is the chain that we deployed our smart contract to. We will then create a function called connect wallet client. So this will let us connect our MetaMask wallet to our front end. That's what this client is going to be doing. Inside this function, we'll need to check first to make sure that we have window.ethereum. That's going to be the object that's provided by MetaMask or a different Web3 wallet. We'll go ahead and check for that. If we don't have that, then we will just return null. But if we do, we'll set our transport equal to custom window.ethereum. Once we've got that transport created, we can then declare our wallet client. So let's actually create the client itself. We'll create a wallet client, and we'll say the chain is Sepolia, and then our transport, how we're connecting to things, is through window.ethereum. And finally, we'll return that wallet client. So that's going to be for connecting our wallet client. We're also going to create a similar function, but a much easier one for connecting to a public client. So again, we have our function called connect public client. Here, we'll create that public client on Sepolia again, and this time our transport is going to be the RPC endpoint for Sepolia. So this is a public entryway into the blockchain. This is what we'll use to read the jokes from our smart contract, and then we return that public client. So we'll give this file a save, and just like that, everything that we need to connect to the blockchain is set up and ready to go. From here, let's work on building out the actual front end. Before we get going with that, Let me go ahead and start our server back up so that we can see changes as we implement them. Okay, so that's running. I'm going to go ahead and move this down just a little bit. And we'll go back into page.js. So right now we just have hello, right? It's not that much. It's not very interesting. Heck, we don't even have world. So let's go ahead and get rid of all of this and we'll start building out our application. All right, so we're going to build this a little bit out of order just to make things quicker for the demonstration purposes of this tutorial. But the first thing we're going to do is we've cleared this out. We've gotten rid of everything in page.js. Let's go ahead and add page back in. So we have our const page and we export it, right? We're good to go there. Next, we're going to import a few things. We're going to use clients so that we can run things on the client's machine. We're going to use state from React. We're going to have a component or two, one for a card, that's where the joke will be, as well as a button. We'll use that for next and previous jokes. And then we're going to use a hook for use jokes. They'll actually let us pull those jokes off of the blockchain. We'll create those components here in just a moment and that hook as well. So inside our const page, we're going to have current joke index and set current joke index using state. We'll start at 0 for our index, and then we'll get our jokes from the use jokes hook that we'll be building momentarily. Once we've got that, we'll need to implement logic for the next and previous button. So we have a handle previous joke, handle next joke, where we use that set joke index for the previous or next joke. Now, previous index in here might be slightly confusing as you're reading through this, right? We'll set the joke index and we're passing in the previous index. In my mind, if we're changing the current joke index, then what it is currently is going to become the previous joke index. So we'll set that, and then the value that we're getting back when we set our joke index is going to be either the previous index -1 or +1, depending if we're going backwards or forwards a joke. Once we've got that done, let's go ahead and add a little bit of HTML to our return here. So we have a div with the class name because we're using Tailwind. You'll notice that it's relative. The height is going to be full screen. We're using our background of the person background to have that sweet dad outfit on our background. We also have a absolute div here to kind of center things in the middle. And then we have our font sans, which is going to be that Comic Sans font that we created and imported earlier, as well as our primary color. So we have dad jokes. They used to be off the chain. Once we have that set up, let's go ahead and use the card and the buttons. So our card, this is going to be what holds the joke. The joke the card reflects is going to be the current index of our jokes that we're going to retrieve. And then underneath that, we're going to have a div with the previous joke and next joke buttons. And that's basically it. That's all we need in this file for right now. We'll give it a save, and let's go ahead and create those other 3 files that we need. So go ahead and we're going to create a new file under source. We'll call this hooks, and then use jokes.js. Again, this is going to be creating the directory and the file itself all in one go. And while we're at it, before we get too far into creating our use jokes hook, let's go ahead and create the components that we'll be adding as well, just so we have those files created. So we'll create components/card.js, as well as one more new file in there called button.js. All right, so we've got 3 files here that we need to fill out. Let's just start with button.js. Here you can see a very basic button component, right? We have our export const button, on click and children are passed in, and on click we have the action that we'll take, and then whatever we're passing in will be shown here. And that's it. We'll give this a save. We'll move on to card.js, and inside card.js, we'll go ahead and use client. We'll create const card. We'll pass in the joke that we're going to be rendering on our card, and then export default card. If there's no joke passed in, we'll return null. This is kind of help out with loading state as a placeholder. If we do have a joke, we'll go ahead and create a div with an h2 for the joke setup, and then paragraph for the punchline. So we're passing in joke object. It has a setup and a punchline that will be shown. And then we have a little bit of Tailwind goodness here that will make things look nice. Again, we're using that amazing Comic Sans style font to add a little bit extra flair to our project. So we'll give this a save as well. And then finally, the last piece that we need to put together in this puzzle is use jokes.js. That's going to be one of our hooks. Within use jokes.js, we're going to use client again. So we run this on the user's machine. We're going to import a few things, use effect and use state from React. We'll also import that client that we created from our lib folder. We're also going to be importing get contract from VM as well as the ABI from our lib folder as well. So these are all the different pieces that we need to connect to our contract where our jokes are stored. Once we have those things imported, we're going to create our public client. So again, we're using the public client, not the wallet client here. So you don't have to connect your wallet in order to read the jokes from the blockchain. You only need to connect your client when you're actually doing something that's going to cause a state change on a blockchain. So you need to sign that transaction. We'll set up the dad jokes contract here using get contract from VM. So we have the address where the contract was deployed. In this case, where does this address come from? This is just a placeholder. Let's get rid of it and let's see how to get this actual address. If we head back to Remix, go to our deploy and run transactions tab where we deployed our dad joke contract. Up here at the top is a copy address button. We can click that, head back to our code editor, paste in the contract's address there, give it a save, and we have our ABI coming from dad jokes ABI, and then our client again is that public client. Once we have our contract set up, we then can create a function to get the jokes themselves. So we'll have export const use jokes. There we'll use jokes and set jokes from use state. We use effect to fetch our jokes. Again, this needs to be async just to make sure that we can await the value to return back from the blockchain. Inside this function, we'll have a try where we can try and get our fetch jokes from using the dad jokes contract value that we set up above to read the get jokes value. So what this is doing is this is going to run get jokes from our smart contract, right? So we have get jokes here. That's what's being run right here. We're reading from our contract and getting jokes. And then whatever comes back, those fetched jokes, we'll use set jokes to set the value to the array that's returned. If anything goes wrong, we have our catch error here and log that error out. Finally, we need to actually run fetch jokes itself. So this will actually call the function, and then we need to return the jokes. So this hook will run everything that we need to run and return back the jokes for us. And with that, I do think that our application is ready to give a refresh. Let's go check out our local host here. We'll give it a refresh and see what's going on. Cool, so we have dad jokes. They used to be off the chain, and look, our joke comes through. So not false, it's funny because it's true. Our next joke and previous joke buttons are maybe working, maybe not working, right? We can click on them and don't see anything because right now we just have one joke. So let's go ahead and add another joke here into our contract. Let's see, what's a good dad joke? I dropped my steak on the ground and got a discount when I was at the grocery store. You know why? Because now it's ground beef. All right, we'll see if that joke gets any rewards. So we'll go ahead and add this to our contract. We'll wait for that transaction to come through. Cool, we can see here. If we go ahead and click get jokes here, you can see, hey, we've got 2 jokes now. Let's see if our front end picks it up as well. So we'll give our page a refresh. It's reading from the blockchain. If we click next joke, we don't see anything yet. Sometimes it takes a second, depending on where the RPC is, to pick these changes up. So if you add something and you don't immediately see the change, don't freak out. Just give it a second. Maybe go grab a drink of water. Hydration is key. And refresh in just a moment. All right, so we'll give our page a refresh here. And we can see we have our not false joke. And if we go to next joke, we can see I dropped my steak on the ground and got a discount because now it's ground beef. All right, so we have 2 dad jokes. Our next button is working. It's wrapping around. Our previous button seems to be working as well. Awesome. So this is a full-blown dApp already, in my opinion. We're reading from the blockchain, displaying it on a front end. Awesome work. Like, congratulations, you've made it this far. Let's go ahead and add the rest of that functionality so that we can reward jokes if they're funny. And then we can also withdraw those rewards if we added a joke. And we'll need to add jokes as well, give ourselves that ability from the front end. We'll go ahead and start by creating a connect wallet button that will let us connect our wallet to this application. In order to do that, we'll need to add a couple of files. I'll go ahead and just add them now. So we can clean this up, close down things that we're not going to be using, and then we'll add the component that we need here. So we'll add a new file to our components. We'll call this connect wallet. We'll add a new hook as well called usewallet.js. And let's go ahead and start with usewallet.js. Within usewallet.js, we'll go ahead and import a few things. Again, useState, our Connect Wallet client from libclient, and format ether from VM. Now, I'm going to go ahead and add some stuff in here that we'll use for withdrawing the balance as well, just to save ourselves a step, because I know that we're going to need that information in the near future. So we'll have our function useWallet. It's going to take in our dad jokes contract. Inside there, we'll go ahead and use state for both the address and the balance. And then we'll create a function called handle click. So when somebody clicks on this wallet connect button, this is what's going to happen. Inside here, we have a try and a catch. We'll add the catch in just a moment. So we'll go ahead and set up our wallet client from Connect Wallet Client that we imported from our library. If we have a wallet client, if it's not equal to null, then we'll go ahead and get the address from that wallet client using request address. So what this is going to do is going to connect to that wallet and say, hey, wallet, what's your address? We'll use set address to set the address. And then we'll go ahead and get the balance of that wallet from our dad jokes contract. So when we created our dad jokes contract, in fact, let's just go take a look at it right now. When we created our dad jokes contract, we had this mapping in here of addresses to a value, and those are our creator balances. Now we're using that creator balance here. We're reading it for our address that's connected through the wallet. See what is the balance of this wallet. Once we have that balance, we'll go ahead and set the balance. Again, we're using format ether from the big int. It comes back as a massive number because it's formatted in way. So we format that in a nicer to read ether format. We'll see what that looks like here in a moment. And then if there's an error, we go ahead and alert with, hey, the transaction failed. Once everything is done, we return back our address, our balance, and that handle click function. From here, we'll give this a save. The next thing that we need to do is we need to go into our Connect Wallet component and build this out. Within the Connect Wallet component, we have our basic imports again, importing in that hook that we just created, use wallet, a connect button component that we'll create momentarily, React imports. We've got our client imports for our wallets, both public and the MetaMask wallet. Get contract from VM so that we can use our dad jokes contract as well as the ABI for that contract. In our component itself, we'll go ahead and set up a few variables for our public client, our wallet client, our dad jokes contract, our address, balance, and that handle click function that we created in our hook. Now we'll use useEffect to initialize both the public and wallet clients. Here again, we're just setting ourselves up for the future because we know that we'll need to interact with both reading things publicly from the blockchain as well as interacting with the blockchain when we reward the jokes, withdraw value from the contract, and submit new jokes. That's where we're going to need both those clients. We're just setting them up now because we'll be using them shortly. Once we have that done, we useEffect for our dad jokes contract to get that as well, and we set that up, our dad jokes contract. Then we check and see if we have an address. So this address is coming from our Web3 wallet, our MetaMask wallet in this instance. If we don't, we're going to return that connect button component that we'll be creating momentarily. If we do have an address, then we'll return connected for right now. This is where we'll put more of that functionality for rewarding, withdrawing value, etc. So we can give this a save, and things aren't going to look too great on our front end yet because we don't have that component that's rendering. So let's go ahead and build out that next component. We'll call it connectButton.js. Within connectButton.js, we'll go ahead and set up our basic component skeleton here. We're going to import image from next image because we'll be using an image for the MetaMask logo. We'll call our component connectButton, pass in handle click. Now we have a div, we'll justify it in the center. Within that div, we're going to create our button. And on click, we'll use that handle click that we're passing in. Again, we have some styling here just to make things look nice. We're using our colors and our amazing font again. What this button is going to have on it is an image from MetaMask itself. So we're using a SVG that we're grabbing from Wikipedia. and using that with the image component that we got from Next. And we'll have a H1 there that says connect wallet. So give this a save. And at this point, I think that we should be good to have our connect button. Our connect button is getting handle click passed in, which comes from our Dad Jokes contract. And if we take a look at our front end, things aren't working. Why not? Let's inspect and take a look at the console and see why things aren't working. If you're following along, you're probably like, hey, silly, you didn't add it to the page.js. Little things like this, man, they can cause you a lot of time. I'm going to go ahead and leave this little mistake in here because sometimes things like this happen and they can be super frustrating. So how do we figure this out, right? I'm looking here and I don't see my button. I don't see any errors though when I take a look at the console. So that made me think like, it's not that something isn't working. It's just that something maybe isn't there. So if we come back to our page.js, we're going to need to go ahead and import connect wallets from components, connect wallet. So we'll come down here underneath the buttons and we'll add the connect wallet component down here, passing in the index and the joke. We'll give this a save. We'll head back and we'll notice, our connect wallet button has appeared. So now we can connect our wallet, and when it's connected, it says connected. But what did that do, right? I've already connected to this URL before. So in MetaMask, if you want to see what it looks like when you connect your wallet, you can come up here to connected sites, disconnect, give it a refresh, connect wallet, and now it's going to prompt you, hey, which account do you want to use? We'll click next and we'll confirm that connection, and now it's connected. All right, so we've got our wallet connected. Now let's add that functionality to reward a joke. In order to add the reward joke functionality, we're going to add a new component that we'll call reward section. And we're going to go ahead and add a new hook as well called useVote.js. Within our hook here, we'll go ahead and import Sepolia from VM Chains, as well as our parse ether from VM Utils. We'll set up our function useVote. We're going to create another function with inside of it called handle vote that takes in the index and the type of reward that we're going to be doing. Remember, that's 1 through 3, depending on if it's a classic joke, it's actually funny, or it's a real groaner of a dad joke. We'll take our reward type, we'll add 1 to it because we're going to be passing in a 0 through 2, and we need it to be 1 through 3. So we'll instantiate our wallet client here and get back the address that we'll be using. I will wait for the wallet client to switch change to Sepolia just in case somebody isn't on Sepolia. If they're on a different network, we'll go ahead and do that. We'll create a variable for the reward amount. And then based on the value that's passed in, we have a switch here that will take in that type and set the amount of ether that we're going to reward the joke with to the proper amount for our contract. Once we've done that, we're going to simulate the contract call. So what this does is it makes sure the contract call is going to work. It uses that public client, checks to make sure the call should run successfully. There aren't any issues with how we're requesting this. And it's going to save that into a request object. So we pass in the address of our contract, its ABI, what function we're going to be calling, any arguments like the index and the reward amount, what account we're going to be calling it from, and then any value that we're going to be passing along. In this case, that's a reward amount with our message. Once we've done that and it simulated it, make sure it's going to run correctly, we're going to actually write to the contract, so write to the blockchain itself with that reward. This is what's going to actually be making that change, adding value for the creator of this joke. And then we have a return handle vote. So that's the function that we have. So this is what's going to be in our hook. We'll give this file a save and we'll head to reward section. Reward section is a pretty basic component here. We'll set it up with our const reward section. We're going to pass in the index and that handle vote function. In our return, we're going to have a div just with some text that says, hey, reward the joke. And then we're going to have 3 options here. We're going to have the classic, just with the laughing, rolling on the floor laughing for those funnier jokes. And then, oh man, that one's a groaner for the final one. So we'll give this a save as well. And we'll head back to Connect Wallet. Inside Connect Wallet, this is where we need to add in our reward section. So we head back to the top here in our imports. Maybe we could organize these a little bit nicer, but I'm just going to add them in their own little section here. We're going to import use vote from hooks use vote. And we're also going to import reward section from, just to keep things consistent, we'll say at components /reward section. We'll add another hook here for const handle vote equals use vote that we're importing up above. We're passing in the contract and our two clients. And then finally, within our return, when we do have an address here, instead of just div connected, let's go ahead and use our reward section. And we'll connect our wallet. And it looks like we have an error. Index is not defined. We need to pass in index to our wallet button up here. So here, we'll say that we want to pass in index. So we'll give this a save again. We'll go back, we'll connect our wallet again. And now we can see, hey, check it out. We can actually reward our joke. So I don't know which one you think is funnier. I think this one's funny because, you know, it's true. It's probably a groaner. We'll click on groaner and we'll notice that our MetaMask pops up. Our amount that we're going to send is correct here. So we'll click confirm and we've just rewarded this joke. Now, the same wallet that rewarded it is going to be the one that's going to be able to withdraw that value as well because I'm all using the same account. So let's go ahead and add that functionality as well, the ability to withdraw from our account. In order to withdraw, we're going to add another hook. We'll call this use withdraw.js, as well as a component called withdraw section.js. All right, things are getting kind of messy here. I'm going to reorganize everything. I still want connect wallet as well. So we'll close to the right. Use withdraw, our hook. Let's go ahead and build that out. So use withdraw, we're going to use Sepolia again from VM. We have our function declaration here that's going to take in the dad jokes contract as well as our two wallet clients. Inside that we have another function called handle withdraw. Inside handle withdraw, we're going to get our address from the wallet client.request address. Again, remember that's pulling it from MetaMask. Then we're going to check and make sure that we're on the right chain. So if we're not on Sepolia, we're going to ask it to switch to Sepolia. Once that's done, we're going to use that public client again to simulate our request. Anytime that we're making a request to the blockchain, the way that VM likes you to do things is to simulate it first, store that request object, then use that request object to write it. It kind of just helps to make sure that you're not going to have any errors. So in this case, what we're doing is we're passing in the address again for our contract. We have our ABI. The function name that we're calling is withdraw balance. If we take a look at our contract, again, remember we have that withdraw balance function that we created here. So that's what we're going to be calling. And then the account that we're calling it with is going to be the address. So we'll wait for that to come back. And then finally, we'll return this function. So our hook returns the handle withdraw function. We'll give this file a save and we'll head to our component withdraw section. Withdraw section is a fairly simple component here. We'll go ahead and set up the skeleton for it. We're returning that export default withdraw section. It's going to take in two values, balance and handle withdraw. It's going to be the balance of the address that's connected to our application, as well as that handle withdraw hook. Inside here, we have a little bit of complexity in that we're checking to make sure before we return anything that we have a balance that's not equal to null and it's greater than 0, or that there's not a balance. If that's all true, then we return this div with a balance, showing the balance in ETH. Remember, balance is what we got when we used our connect wallet hook, use wallet. We return that balance back. And then within there, we have a button to cash out that will actually run handle withdraw, that hook that we just created. So we'll give this a save. And the next thing we need to do is we need to, within connect wallet, we need to import use withdraw from hooks, use withdraw. And we also need to import withdraw section from, and again, it likes to just do it all at once, but I like to keep things consistent. So components, withdraw section. And then we'll need to add this down below within our return as well. So here we'll add it in. I put it inside its own div here just to make things a little bit nicer. So you can see we're passing in our handle withdraw and our balance. The one thing we need to do is declare handle withdraw up above so it knows what that is. I forgot to do that a moment ago. So go back up to the top here below handle vote. We'll say handle withdraw is use withdraw, and we're passing in the contract, the wallet client, and the public client. We'll give this a save. We'll head to our application. We'll connect our wallet, and you can see, hey, look at that. We have a balance of 0.01. That's the amount that we gave it with this Groner. So at this point, we can click cash out, and you'll see, hey, look at this. We'll receive 0.1 ETH. That's awesome. So at this point, we can reward jokes. We can get the value back out. The only thing left to do, we are so close to having a fully functional application here, is adding a joke in. So let's go ahead and get that done and wrap this project up. So in order to add a joke, we're going to add two more things. The first is a modal for the jokes to be added. We'll add a new component here, and we'll call it jokemodal.js. And we'll also add a hook called useSubmitJoke.js. We'll build out the hook first, as we've been doing already. We'll import useState from React. We'll import Sepolia. That should look familiar. We have our function useSubmitJoke. It takes in our two clients and our dad joke contract. We'll set a const isModalOpen, and we'll use state for that. We'll default it to false. We'll have a function for our handle submit, where we take in a setup and a punchline. Inside there, this should look familiar. We're getting address from our wallet client. We'll wait for it to switch to Sepolia just in case we're not there. And then we will simulate our contract, store the results in request. Again, we're passing in the address. Everything looks similar, except for we have add joke here. That's the function that we're calling. Our arguments are going to be the setup and the punchline. If we take a look at our contract here, we can see that when we want to add a joke in, we're taking two values, the setup and the punchline. So that's what we'll be taking into our contract here, the setup and the punchline. Those are the arguments. We will await for the right contract, and then we will set our modal to false, so it won't be open anymore. So we'll open up that modal, let somebody enter stuff in. Once they click submit and it processes adding their joke, we'll go ahead and close the modal, and then we'll return the modal open state, set modal open, and the submit value. So we'll give this a save. We'll head to the joke modal. Inside our joke modal, we'll set up our joke modal to take in the is it open, set is it open, handle submit, setup, setting the setup, the punchline and setting the punchline. We have our return here in our export default. Inside our return, if our modal is open, then we want to create a couple divs, nice little floating gray box here. We'll have two input values, with one being the setup, the other being the punchline. On change, we're going to run set for both of them. And then we'll have a nice submit button and a cancel button as well. The submit button will run handle submit, which is that hook that we just created. The cancel button will just close the modal. And that is it. We'll give this a save. We'll head to Connect Wallet here. Possibly Connect Wallet is a little overloaded. Maybe we should do things a little bit differently and clean them up. But I don't know. It works. It's not too messy. It probably could be refactored slightly to improve things. So within here, we'll go ahead and add another import section. We'll say import, and we'll say use submit joke from hooks submit joke. We'll also say import joke modal from @components or @/components /joke modal. We'll need to go ahead and set up that joke modal stuff here. So we say, is the modal open, set it open, handle submit. Those are all coming from our hook, use submit joke. We're passing in our clients and our contract. Once we have that set up, we can go down below to where our return is. So we have our reward section. We have our withdraw section. Let's go ahead and add a button into that same section here. So this is going to be right underneath the withdraw section. We'll add in a button right here. So we'll add in this button to add a joke. And then we'll also add in our joke modal, passing in the values that we need. We can give this a save. Go back to our contract, and it looks like Something's not set up correctly on line 92. Setup is not defined. It looks like I forgot to add our setup up here as well as the punchline. So right here underneath this, we can just go ahead and add in our const setup and our const for punchline. Go check it out, connect our wallet. All right, so we don't have cash out because we already cashed out, but we can now add a joke. So what is another classic dad joke that we can add? This one's kind of long. It'll probably break the formatting. But did you know most people are born with 4 kidneys? It's a true fact. As they get older, 2 of them turn into adult knees. It's pretty bad. I don't know. It might be worthy of a groaner. But we click submit and we can confirm. And we wait for this transaction to be confirmed and see our amazing dad joke added to our application. So we're waiting for this pending to be done. All right, it's confirmed. If we give our page a refresh to pull the information off the blockchain, it may take a moment again. So if I go to previous joke, I'm not seeing it just yet. So wait a moment for it to be added to the blockchain where the RPC that we're using can actually see it. All right, so it's been a minute and I'm not seeing my joke show up here. And I think I just realized why. There was one more place where I needed to change the address of our contract. So here, this is again a placeholder address. I need to paste in the contract address. So we'll go back to Remix, snag it, make sure it's the right one. This is inside connectwallet.js. Under the use effect here, I need to paste in our address. So you'll notice ended in 6ED. I'll paste it in Zentindi now, give it a save. Everything's going to look the same. I was just interacting with the wrong contract. So again, I'll connect my wallet. I'll add a joke. We'll say, what do you call a fish with no eyes? And we'll submit that joke. It may look like it was a bug, but it was really just an opportunity to give you one last dad joke. We'll wait for this transaction to be confirmed. Here, it looks like it is. We'll give this a refresh. Now we'll look at the previous joke. It's not showing up there, but if we go to Remix, click on Get Jokes, you'll see that it shows up here. So it may take a minute to show up on the front end with that RPC endpoint that we're using. But if we wait and give this a refresh, it should show up eventually. And that is how you build a full stack dApp with Next.js, Tailwind, a smart contract, and VM. Make sure you drop your favorite dad joke in the comments below. I'd love to read them. And don't forget to like this video and subscribe. All that YouTube stuff. Thanks for watching, and I'll catch you in the next one.